From a point smaller than an atom to the universe we see today, the Big Bang is the most mind-blowing event imaginable. It's a story of creation, of expansion, and of the fundamental forces that govern our cosmos. Over the next 10 minutes, we'll embark on a journey through time and space, exploring 10 fascinating facts about the Big Bang. We'll delve into the evidence that supports this extraordinary theory, from the faint afterglow of creation to the accelerating expansion of the universe. Prepare to have your mind blown as we unravel the mysteries of the Big Bang and gain a deeper understanding of our place in the vast cosmic tapestry. Imagine a time before time existed, a place where all matter and energy were concentrated into a singularity, an infinitely dense point. The Big Bang theory proposes that around 13.8 billion years ago, this singularity began to expand rapidly, creating space and time as we know it. In the first fraction of a second, the universe underwent an exponential expansion known as inflation, growing from an infinitesimally small point to an astronomical scale. As the universe expanded, it also cooled, allowing for the formation of the fundamental forces and particles that govern our universe. The Big Bang wasn't an explosion in the conventional sense, like a bomb detonating in space. Instead, it was the expansion of space itself, carrying all matter and energy outward. It's a concept that challenges our everyday understanding of physics and forces us to grapple with the truly mind-boggling nature of the universe. But the Big Bang theory isn't just a wild idea. It's supported by a wealth of scientific evidence, from the cosmic microwave background radiation to the observed redshift of distant galaxies. These pieces of evidence, like puzzle pieces, fit together to paint a compelling picture of our universe's origins. How can we possibly know what happened billions of years ago? The universe, thankfully, has kept some receipts. The first piece of evidence is the redshift of distant galaxies. Just like the sound of a siren gets lower as it moves away from us, light from distant galaxies gets stretched, shifting towards the red end of the spectrum. This redshift tells us that these galaxies are moving away from us, and the farther away they are, the faster they're receding. This observation implies that the universe is expanding just as the Big Bang theory predicts. But the smoking gun evidence for the Big Bang comes from the cosmic microwave background radiation, or CMB. This faint afterglow of the Big Bang permeates the universe and provides a snapshot of the universe just 380,000 years after the Big Bang. The CMB's existence, its temperature, and its subtle variations all align perfectly with the predictions of the Big Bang theory. Imagine a time when the universe was so hot and dense that atoms couldn't even form. Instead, protons, neutrons, and electrons existed in a chaotic soup, constantly interacting with light. As the universe expanded and cooled, a pivotal moment occurred. The temperature dropped enough for electrons to combine with protons and neutrons, forming the first neutral atoms. This era, known as recombination, marked a significant change in the universe's transparency. Before recombination, the universe was opaque, like a dense fog, with light constantly scattering off free electrons. But after recombination, the universe became transparent, allowing light to travel freely for vast distances. Chapter 4. An ever-expanding cosmos. The expansion of the universe. One of the most mind-boggling concepts about our universe is that it's constantly expanding. This expansion isn't like the explosion of a bomb where fragments fly outward into pre-existing space. Instead, it's the very fabric of space itself that's stretching, carrying galaxies along for the ride. And imagine a balloon with dots drawn on its surface. As you inflate the balloon, the dots move farther apart, just like galaxies in our expanding universe. But here's where it gets even stranger. Not only is the universe expanding, but the rate of expansion is accelerating. This discovery, which earned the 2011 Nobel Prize in Physics, suggests that a mysterious force dubbed dark energy is driving this accelerated expansion. Chapter 5. From Singularity to Galaxies. The Timeline of the Big Bang. The Big Bang isn't just a single event, it's a continuous process of evolution that has unfolded over billions of years. Let's take a journey through time and explore the major milestones in the universe's history. In the first fraction of a second after the Big Bang, the universe underwent a period of rapid inflation, expanding from an infinitesimally small point to an astronomical size. During this time, the fundamental forces of nature separated and the first elementary particles such as quarks and leptons began to emerge. As the universe continued to expand and cool, quarks combined to form protons and neutrons, the building blocks of atomic nuclei. Around 380,000 years after the Big Bang, the universe cooled enough for electrons to combine with protons and neutrons, forming the first neutral atoms. This era, known as recombination, marked a crucial turning point in the universe's history as it became transparent to light. Chapter 6: The Forge of Elements, Formation of the First Atoms. In the first few minutes after the Big Bang, the universe was a hot, dense soup of protons, neutrons, and electrons. As the universe expanded and cooled, conditions became just right for a process called Big Bang nucleosynthesis to occur. During this brief period, protons and neutrons collided and fused together, forming the first atomic nuclei. The vast majority of these nuclei were hydrogen and helium, the two lightest elements in the universe. Trace amounts of lithium and beryllium were also produced. This process of Big Bang nucleosynthesis is responsible for the abundance of hydrogen and helium we observe in the universe today. Chapter 7: The dark side of the universe, dark matter and dark energy. The matter we can see, the stars, planets and galaxies, only make up about 5% of the total mass and energy of the universe. The remaining 95% is composed of mysterious entities known as dark matter and dark energy. Dark matter doesn't interact with light, making it invisible to our telescopes. However, its gravitational influence can be observed in the rotation of galaxies and the large-scale structure of the universe. Dark energy, on the other hand, is a mysterious force that's causing the expansion of the universe to accelerate. Chapter 8: From gas clouds to star nurseries, formation of galaxies and stars. After the Big Bang, the universe was filled with a vast expanse of mostly hydrogen and helium gas. Over time, gravity began to pull these gas clouds together, forming denser and denser regions. As these regions collapsed under their own gravity, they began to spin, creating swirling disks of gas and dust. At the centers of these disks, the temperature and pressure became so intense that nuclear fusion ignited, giving birth to the first stars. These early stars were massive and short-lived, ending their lives in spectacular supernova explosions. Chapter 9: The Fate of the Cosmos, Future of the Universe. The universe is constantly evolving, and its future remains one of the most intriguing questions in cosmology. The fate of the universe depends on the interplay between the expansion of the universe and the gravitational pull of matter and dark energy. One possibility is that the universe will continue to expand forever, growing colder and darker as galaxies move farther apart. In this scenario, known as the Big Freeze, stars will eventually burn out, and the universe will become a vast, empty void. Another possibility is that the expansion of the universe will continue to accelerate, leading to a big rip. In this scenario, the fabric of space-time itself would be torn apart, destroying everything in the universe. Chapter 10: Unanswered Questions, Mysteries of the Big Bang. While the Big Bang theory is the most widely accepted explanation for the origin and evolution of our universe, it still leaves some profound mysteries unanswered. What existed before the Big Bang? What caused the initial singularity to expand? What is the nature of dark matter and dark energy, which together make up 95% of the universe? The expanding mystery. From the cosmic microwave background radiation to the accelerating expansion of the universe, we've uncovered evidence that paints a compelling picture of the Big Bang. We've explored the formation of the first atoms, the birth of stars and galaxies, and the mysterious roles of dark matter and dark energy. The Big Bang theory is a testament to the power of human curiosity and our relentless pursuit of understanding the universe. What other secrets does the universe hold? What new discoveries await us as we continue to explore the cosmos? Like, comment, and subscribe to join me on this journey of cosmic exploration.